Hello students. In this video, we'll be exploring the fascinating world of carbon and its compounds. Carbon, as you may know, is a fundamental element that forms the backbone of countless compounds, making it essential to the chemistry of life. Let's begin by understanding the structure of carbon. Carbon has an atomic number of 6, which means it has 6 protons and 6 electrons. These electrons are arranged in 2 shells, with 2 electrons in the innermost shell and 4 in the outermost shell. This arrangement gives carbon a valency of 4, meaning it can form 4 covalent bonds with other atoms. This tetravalency is a key feature of carbon, allowing it to bond with other carbon atoms as well as a variety of other elements, forming an almost limitless number of compounds. One of the remarkable properties of carbon is its ability to form long chains and rings through a process called catenation. This property allows carbon atoms to bond with each other, creating a wide range of structures, from simple straight chains to complex branch molecules and rings. This ability to form diverse structures is what underpins the vast diversity of organic compounds. Carbon exists in several different forms, known as allotropes. The most well-known allotropes of carbon are diamond, graphite, and graphene, each with unique properties due to their different atomic arrangements. Diamond, for example, has a 3-dimensional crystal lattice where each carbon atom is bonded to 4 others, giving it incredible hardness. Graphite, on the other hand, consists of layers of carbon atoms arranged in hexagonal patterns. These layers can slide over each other, making graphite soft and slippery. Graphene, a single layer of graphite, is incredibly strong and an excellent conductor of electricity, opening up exciting possibilities in electronics and materials science. Carbon's ability to form covalent bonds leads us to the concept of covalent bonding, where atoms share electrons to achieve stable electron configurations. Carbon typically forms covalent bonds with other non-metal atoms, including hydrogen, oxygen, and nitrogen. These covalent bonds are strong and directional, allowing for the formation of stable, complex molecules. When carbon bonds with other elements, it often forms organic compounds, which are primarily composed of carbon and hydrogen and may include other elements such as oxygen, nitrogen, and sulfur. Organic compounds are the foundation of life, making up everything from the DNA in our cells to the fuels we use for energy. Among the simplest organic compounds are hydrocarbons, which consist solely of carbon and hydrogen atoms. Hydrocarbons can be classified into 2 main types: aliphatic hydrocarbons, which include alkanes, alkenes, and alkynes, and aromatic hydrocarbons, which contain rings of carbon atoms, like benzene. Alkanes are saturated hydrocarbons, meaning they only have single bonds between carbon atoms, while alkenes and alkynes are unsaturated, containing double or triple bonds, respectively. Hydrocarbons can also exhibit isomerism, where compounds with the same molecular formula have different structural arrangements. These different structures, known as structural isomers, can have vastly different chemical and physical properties, even though they are made up of the same atoms. For example, butane and isobutane both have 4 carbons and 10 hydrogens, but they have different structures and, consequently, different properties. Another important concept in organic chemistry is the idea of functional groups. These are specific groups of atoms within a molecule that determine the chemical reactivity of that molecule. Common functional groups include hydroxyl groups, carbonyl groups, and carboxyl groups, each imparting distinct characteristics to the molecules they are part of. Organic compounds can also be classified into homologous series, where each successive compound in the series differs by a methylene group. Members of a homologous series share similar chemical properties and show a gradual change in physical properties, such as boiling points, as the molecular size increases. When it comes to the chemical properties of carbon compounds, they exhibit a range of behaviors. For example, carbon compounds can undergo combustion, where they react with oxygen to produce carbon dioxide, water, and energy. This property makes hydrocarbons excellent fuels. Carbon compounds can also undergo oxidation, addition, and substitution reactions, which are fundamental to many chemical processes, including the production of various industrial chemicals and pharmaceuticals. Two important carbon compounds that we encounter in daily life are ethanol and ethanoic acid. Ethanol, commonly known as alcohol, is a volatile liquid used in alcoholic beverages, as a solvent, and in medicines. It reacts with sodium to produce sodium ethoxide and hydrogen gas, and it can also undergo dehydration to form ethene. Ethanoic acid, also known as acetic acid, is the main component of vinegar and has a distinctive sour taste. It reacts with alcohols to form esters, which are used in making perfumes and flavorings, and it can also react with bases and carbonates to produce salts. Lastly, let's talk about soaps and detergents. Both are used for cleaning, but they have different chemical compositions and properties. Soap is made from natural fats and oils, forming molecules with a hydrophobic tail that dissolves in grease and a hydrophilic head that dissolves in water. Detergents, on the other hand, are synthetic and are more effective in hard water, as they do not form insoluble precipitates with calcium and magnesium ions. Now, here's a question for you to test your knowledge. What is the term for the ability of carbon atoms to form long chains by bonding with each other? Please share your answer in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.